Hi, Ryder, or R to the third here, and today we're going to be looking at another algorithm problem, and this is just part of my basic algorithm series. And this time we're going to be looking at a problem that is going to be using um, sets as well as kind of an idea of using memory to find a better solution. So the goal today is to approach this problem, and then from there, we'll kind of take a more naive approach, and then we will go and dive deep into a more informed approach that may be a little better. So yeah, let's just dive into this problem and read it. I actually haven't done this prior, and so we'll see how this goes. So given a string s, find the length of the longest substring without repeating characters. So for instance, if we have this string, it's 3 because ABC is the longest repeating characters. And so, honestly, this is pretty simple. And so, if I'm taking a naive approach to this, really, a brute force approach is going to be just looking at every possible substring within our string and checking if it has repeated characters. And so we'll go ahead and code that up first. And so first we have to generate every possible substring, or basically we can do for int I equals 0. And so for instance, let's just start by visualizing this. We have A, B, C, D, and I'm going to put spaces here. And we have 1, 2, 3, 4 as our indices. We're going to want 1 to 1, and we'll want 1 to 2, and then we'll want 1 to 3, and we'll want 1 to 4. Then we'll check the substring 2, 2, and 2, 3, and so on and so forth until we check every substring. Now this is not efficient at all, and I completely understand, but let's go ahead and do this before looking at how we get to the better solution. Because in order to understand where the better solution maybe comes from and how we can think about getting there, we should think about the possible ways we could get there. So I'm going to declare an int longest length is 0 to start out with. And so if some function if contains no duplicates, s.substring from I to j, do something, right? And this is where we're going to consider then if j minus I is greater than our longest length, we will make longest length equal to j minus I. And then we will return longest length. And we'll go ahead and run this on a test case to verify that we're doing it right before we dive in. But so let's make a private Boolean function contains no duplicates. It's going to take in string s, and so then we're going to utilize a hash set for this, right? That way we can be just looking at if there are any unique characters. So that's going to be the easiest way to do it. And actually, before we abuse the hash set, let's do this kind of the stupid way. Let's do this the incredibly stupid way, because this should be +1 here. Anyways, let's do this the incredibly stupid way of doing a double for loop. I will explain why this is a pretty bad approach in a second. but let's go ahead and do it. And so if s dot at car at I equals j, return false, otherwise return true. Is this going over every element? Yes. So this is going to make sure that there are no two indices with the same thing. Yes, this is a super naive approach, super utilizing arrays. Let's just verify the default test cases this even works. And so actually, I guess we didn't need the +1. It's my bad. Oh, this is where the +1. We should always start ji plus 1. I think that's the bug. This is kind of a silly way to do it. And this actually may even time out on like a super long edge case. This is what I was worried about, was actually the edge case with the 0 in it. Or not a 0, but a length of 0. So we're going to do this, and this is, again, a horrible way to capture it, but we should probably check the null case, right? So if either of these, we can return 0, else return longest length equals 0. Otherwise, we return 1 or longest length. Now, this isn't probably the cleanest solution. Not very much a fan of it. But this is more to demonstrate the purpose. And this is funky. So why are we getting this? Well, let's think of this. So, well, I is less than the length. Go through the list. Why not just do the here's a lazier way to do it. String cur equals this. Construct the string. Call current. And this will probably make it maybe a little easier. Maybe a little more readable. Really, we could replace this with a math.max call or whatever. But this will suffice. And that's interesting. Now, I'm wondering if I'm forgetting how strings work. Maybe this needs to be less than or equal to. Which could be my error. I don't think that's true, but yeah, there we go. Okay. I forgot that substring needs to actually go like one character out of the typical index. Which is completely silly. So now we get a time limit exceeded, right? And there's a couple of things we could try to fix this. The first is going to be, we have a pretty terrible runtime here, right? So we have O of n squared right here, where we're calling this O of n squared function within O of n squared. And so that's not that great. And so how can we flatten this in some way? And that's going to be to using memory to our advantage. And so right here, we can use a hash set to contain the characters we've actually looked at. And obviously, we need to tell Java it's going to be of type character. So what we can do is we can iterate over the array now, and if every iteration or every character we look at, we can see, is this currently in there? If it is, false. Otherwise, keep going. And so if cars.contains s.car@, I, return false, right? Otherwise, let's look at the rest. But before we can look at the rest, we should do cars.add. I think it's insert. Oh, it's add in Java. Sorry, cars.add. s.car@, I, right? And so now this probably won't even fix it because there's actually another thing we can do. And so you see, we got another time limit exceeded, right? And so now you're just probably sitting here, if you haven't seen a problem of this sort, wondering, well, what can I do? Right? So the problem is, we're trying to look at this from the perspective We're trying to look at this from the perspective where we're looking over every array, right? But the problem is, let's say 1 to 3 was good, and our current longest length is 3, or 2. Well, then we don't need to look at these ones again, because these don't matter. And so what we can do is we can do what we're going to call a sliding window. So for instance here, we're going to look at A, and then let's look at A and B and see if this is valid. Then let's look at A, B, C and see if this is valid. Right. Then let's look at A, B, C, D and see if this is valid. And then if this is valid, okay, let's look at A, B, C, D, A. Oh, this isn't valid, so what do? Well, we can shift this guy over and see if he's valid now. Oh, he is? Then let's move our right guy over. And we can keep sliding this window outwards and inwards until we get at the end and we know we can't increase. And so that's the key here, right? How do we keep increasing and checking? So let's keep this s.length thing. Let's keep all this. Let's change all of the rest, right? And this probably wouldn't even be necessary anymore either. And we can actually even keep this function, although we can do away with it. We actually are going to do away with it because it's going to improve our runtime just a little, not having to make that intermediate function call. But let's get it implemented. So let's do this. Let's first move our hash set of characters up here, right? Okay. And then so we want to have int longest length, int left, right, where left is going to equal 0 and right is going to equal 0 as well. Okay. So wow what? Well, right is less than right is less than the max length, right? Oh well, s dot length is less than or, well, equal to. Actually, can it be less than now? Yeah, I think it can be, because we're going to be changing something fundamentally. We can think about that a little later. I think that's kind of an intermediate detail. We should be focusing on the fact of, well, what are we doing here, right? And so we're going to have a left and a right pointer, right? And we're going to start with this left pointer. we're going to be storing everything in our list. And so if our list, if our cars dot contains s dot at car at right, if it contains the right side character, we need to move left. If it doesn't, we can do right plus plus, and we can do cars dot insert or cars dot add s dot car at right. Otherwise, well, first of all, we need to remove the leftmost characters, right? So cars dot remove s dot car at left. And so we're going to remove that character. We're going to move left. Okay. So boom. That's pretty simple, right? But can our left ever get further than our right? So if left is greater than right, then we're going to set right equal to left. I think this should handle it. I'm not a fan of this line. There's probably a better way to do it. Because really, that should only be happening when we move left. So if left, we should increment right by 1. I think this is going to be a cleaner way to do it. It's kind of more, we trap it up here, then we can look at it. We got to remember what we're returning, right? We're returning longest length. And then, so we should do a check. And we'll just do kind of an easier way, equals math.max between itself and left or right minus left plus 1. And let's see if it needs that plus 1. Let's think about it. Here, this would be 1 minus 0. This would be 2 minus 0. And I think we do need that then. And since we're not doing substring, I think this is right. And, well, we shouldn't need to do in left. Because if left starts getting out of whack, right will be out of whack too. And so I think we should be good here. This whole function can be removed. And let's take a look at what's going on. Let's see if this even works for a test case, and then we can move on. And so we're actually 1 too high. Why is that? Oh, it's because we're incrementing right and then checking it. So this would actually be the new right and not the old right. And so actually we should be checking before. But then that gives us the edge case of what if we're dealing with length 1. I think we wait to get there. Let's think about what we're doing here. We'll go there. So if longest length equals the math max of that, if we're moving left, we should never be getting a better answer. So realistically, you should only be doing it for adding to the right. And even that edge case of a length of 1 would capture it, because 0 is less than 1. It's not going to contain it, so then we're going to add it. we're going to add it plus 1 to here. So, and then we do that. So I think this should work. We know it's going to work for this. So let's see if it just works in general. And it does. And so really it's taking a problem and looking at this from another perspective, and drawing out where you can go from there. If there's any other more effective solutions that you can think of, I gladly love to hear them. This is kind of a cool little problem of using sliding window and hash sets. And yeah, I mean, this shows how you can take an algorithm from something like O of n to the fourth, when you're approaching it very naively, down to O of n, or O of n. And so it's really fascinating when you can make those considerations and those improvements, using some data structures and also taking a different approach. So thank you so much for taking the time to watch this, and like, comment, and subscribe. And thank you so much.